Today's lesson is on expectation. So basically using probability and a number of trials, how many times would you expect to get a specific answer? This will cover pages 192 and 193 in your Jump Math book for 7.2. At the top of your first page, they're going to give you a scenario with Kate. So Kate plans to spin the spinner 15 times to see how many times it will land on yellow. Since 1/3 of the spinner is yellow, right, 1 out of 3 spaces, Kate expects to spin yellow 1/3 of the time. Kate finds 1/3 of 15 by dividing by 3. So she says 15 divided by 3 is 5. So she expects the spinner to land on yellow 5 times. So this is the same as finding an equivalent fraction, right? If we just say 15 divided by 3 equals 5, this 5 will be the same number we would get with an equivalent fraction, right? If we have 1/3 and we want to see how many out of 15 that would be, we're multiplying by 5. So it's just a different way of doing this, and it's a little bit easier and faster, right? So for question 1, they're simply asking you to divide, right? So for 1a, they're asking you to say 2 goes into 10, right? So 2 goes into 10 5 times. 5 times 2 is 10. When you subtract, you have a remainder of 0. Okay, so for question 1, that's all you have to do. For question 2, they're asking you to use long division to find, they'll say, a fraction of a number. So because the top number in each of these is 1, 1/2, 1/3, 1/4, we can just divide by the bottom number. So this wouldn't work if the top number was something different, but in this situation, you are going to divide by the denominator. So for 1a, 1/2 of 38 is the same thing as 38 divided by 2, right? So 2 goes into 3 once is 2, take away equals 1, bring down the 8, 2 goes into 18 9 times, minus 18 is 0. So 1/2 of 38 is 19. So that would be your answer for this question. So that's what you'll do for the rest of these. So when we're finding 1/3, we would divide by 3. Finding 1/4, we would divide by 4. Questions 3 and 4 build on each other, so we'll go through those together. 3 asks, if you flip a coin repeatedly, what fraction of the throws would you expect to be heads, right? So your numerator is going to have just be how many ways could you get heads over the total outcomes when you flip a coin. So in theory, you could get heads or tails, so that would be 2 possible outcomes, but they're only looking for 1, which is heads. So your fraction should be 1/2. Now question 4 asks you how many times you would expect to flip heads if you flipped a coin 12 times, 40 times, 68 times. So you could look at this and go, okay, if I'm flipping it 12 times, I need to find 1/2 of 12. So to do that, you can simply say 12 divided by 2 equals, and that should give you your answer, which can go on the line here. Question 5 says, for each spinner below, what fraction of your spinner would you expect to be red? So for the first question, we've got 3 here. I would expect to spin red. This blank is where they're asking you to put in a fraction. So they actually want you to fill in this spot here with the probability of spinning red. So how many red spaces are there? There's 1 out of how many equal pieces? 3. So you'd expect to spin red 1/3 of the time. So you'll use that same format. For part B, you'll say, I would expect to spin red, put your fraction of the time. Question 6 says, how many times would you expect to spin yellow if you spun the spinner 18 times, 33 times, 69 times? So yellow, our probability of yellow here, we've got 1 yellow out of 3 equal pieces. So basically what we'll be doing is dividing by 3. So what is 1/3 of 18, or 18 divided by 3? Oh, that's 6. So that's what you would put here. What's 33 divided by 3? 69 divided by 3. For the second one, you'll figure out what's the probability. So what's your fraction? What do I need to divide each of these by? Question 7 asks you to sketch a spinner on which you would expect to spin red 3/4 of the time. What is the probability of spinning a color that is not red? Okay, so the bottom number here tells you how many total spaces your spinner should have, and the top number will give you the number of red spaces. So you can draw your spinner that way. It doesn't matter what color you use otherwise. And then they ask what the probability of spinning a color that is not red is. So count up all the spaces that are not red and put that out of the total number of spaces. We're essentially trying to find the rest of the fraction that would take us to 1 whole, right? So 3/4 plus whichever is going to equal 4/4, which is the same thing as 1 whole, right? So this fraction would be the fraction or the probability of the not red spaces. In question 8, we start looking at probabilities that don't have a numerator of 1. They're not a unit ratio. So they ask us to find the fraction of the numbers. So we're doing this in 2 steps. They're not really concerned with us finding 1/3 of 12. Our ultimate goal is they want us to figure out 2/3 of 12. But the strategy they're using is to go back to a unit ratio. So they're saying, okay, 1/3 of 12 is 4. So 2/3 of 12, remember that's going to be double, is 8, right? So if we're here, 1/3 of 21 is this. So 2/3 of 21 should be twice as much. So when we start looking at C and all these other questions, we're going to have to start not with 2/3, but we'll say, okay, our unit ratio is 1/3 of 39 is this. So 2/3 of 39 is this. So because we're going from 1 to 2/3, we'll multiply our first answer by 2. Whereas when we get to question F and we're dealing with 3/4 of 48, we'll still start with 1/4 of 48. And so the way that you would find that is you would divide by this denominator here, right? 48 divided by 4 should give you the answer. So 3/4 of 48 is this. Now, to go from our first answer to our second answer, we're finding 3/4 of it. Sorry, my pen died there for a moment. So if we're finding 3/4 instead of 1/4, we need to multiply our initial answer by 3 to get 3 portions. Question 9 asks you to color the marbles red and green or label them R and G to match the probability of drawing a marble of the given color. So I'll do A with you. So they're asking for the probability of red, which means that's the color we will be shading them in. And we want 3/4 are red, right? So our probability is 3/4, which means 3/4 of the marbles need to be red. So we start by counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 marbles, which means we need to figure out 3/4 of 16. So the way that they've showed us to do this is to find 1/4 of 16 is 4, because 16 divided by 4 is 4. So 3/4 of 16 is going to be 3 times as much, so that is 12. So we need to color 12 of them red. So it doesn't matter which 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so we should be able to make, if you wanted to prove that it really is correct, I'm just going to use yellow to make some groups, right? We have one group, 1/4. So if we made groups of 4, we have 3 groups that are shaded and 1 that isn't. So that's 3/4. So you'll do the same thing for B and C. Count how many dots there are, find that fraction of the total number of dots, and color them in the correct color that they ask for. I'm just going to talk about the rest of the questions on page 193 with you. They're all kind of word problem situations using proportions where they're trying to get you to figure out what you would expect to get from these different events. So question 10 is going to start by asking you how many times you would expect to spin blue if you spin the spinner the given number of times. So this is the color that we're looking for, is blue. So we know we're looking to spin it 60 times. So that means our final fraction, we're kind of looking for something out of 60. And our initial fraction, we can look, if the pieces are all equal, then we can just do the number of pieces out, right? So we'd have 1 out of 3 pieces and then figure what that is out of 60. For the second one, my hint is going to be the blue size piece, or the blue piece, it's not blue sized, is not the same size as all of the other ones. So I would actually take your pencil and create equal sized pieces that are the same size as blue. So I wouldn't think of white as having 1 piece, but I would think of white as having 4 out of 8 pieces, and green is having 2, and then red and blue could each be 1. So just so that helps you figure out your initial fraction for the probability of blue, and then figure out that fraction of 200. For question 11, we have a pie diagram, and it shows, so this is the pie diagram here, it shows the fraction of students at a school who walk, ride the bus, bike, or skateboard to school. What fraction of students skateboard to school? So this is going to be very similar. We've got this section for skateboarding. Now it's not 1 out of 1, 2, 3, 4 pieces, because they're not equal sizes. So I would make sure the first thing you're doing is taking your pencil and drawing lines to separate them into equal sized pieces. Then they say, if you surveyed 200 students, how many would you expect to have biked to school? So your fraction of skateboarders out of 200, what would that fraction be? For question 12, a scientist observes a group of 50 caribou and finds that only 10 of them are male. What is the experimental probability of a caribou in this group being male? So experimental is not theoretical. Here's his experiment. He did an observation, 10 out of 50. You could then choose to simplify that, right? So you could divide them both by 10. Asks what percentage of the group is male. So 10 out of 50, turn that into a percent. So remember, percent, cent in French is 100, so it's always out of 100. For C, the scientist assumes that the observation represents the ratio of the number of males to the number of females in a larger group of caribou during this time of the year. What fraction of a group of caribou should be males? So basically, what is our simplest term fraction from the top question? D asks, how many males does the scientist expect to see in a group of 1,000 caribou? So if he has his initial fraction or his percentage, what would that be out of 1,000? Question 13 has a chart that shows the survival rate, how many birds will survive, under two different environmental protection programs. So if a program could be implemented in only one forest, which one would you choose? So Forest A has 5,000 birds and 80% survive. Forest B has 15,000 and 2 in 5 survive. So the question is a little bit strange because they're asking if a program could be implemented in only one forest, which one would you choose? So we're kind of looking at how many of them actually survive. What is 80% of 5,000? What is 2 out of 5 out of 15,000? What's 2/5 of 15,000? And so then if you see the survival rate and you see how many are not surviving, you probably will want to choose the one that has the most birds that do not survive. Question 14 has a batting average of .427, means a baseball player has 427 hits in 1,000 times at bat. Express the batting average below as the probability that a player gets a hit and reduce your answer to lowest terms. So basically we're putting these as a fraction, right? So to convert from the decimal to the fraction, we're going to the thousands place. So it would be 200 out of 1,000, and then you need to keep dividing the top and the bottom by the same number until you can't divide them anymore. There's no more common factors. Part B asks, say how many hits on average each player is likely to get in 60 times at bat. So once you've simplified your answer, you can figure out what that fraction is of 60, similar to how we did in a lot of previous questions. So I'll do A with you just because this one might be a little bit confusing. So he's batting .200, which means he has 200 out of 1,000 times at bat. Well, I could actually divide these both by 200, and that will give me 1 out of 5. Because if I take off the zeros here, 2 goes into 10 5 times. Then I want to figure out 1/5 of 60 is going to be the same thing as 60 divided by 5, which is 12. So I would expect player A to hit the ball 12 times if he gets 60 times at bat. There'll be a couple of Google questions at the end so you can show me what you know. I know we're wrapping up to the end of the school year, but you're still more than welcome to let me know in the comments if you would like some help with these lessons, and we can go over them in an individual Zoom meeting.